In this module, you will learn new features of ABAP introduced with release 7.4, various syntax enhancements, and at the end of the video, you will be able to write programs using new features. The content of this video is a quick reference guide which gives you the essentials you need and shows you how the code you are already familiar can be improved with ABAP 7.4, which is now extensively expression enabled. This is achieved using modifications like inline declarations and type inference, new constructor expressions, table changes, operators like corresponding group by, and so on. Also, few ABAP existing objects are enhanced, like functional methods and interface methods. All the details are explained going further. Now moving on to the actual changes in ABAP, starting with inline declaration. You can now declare variables on the fly. Observe the source code given in the screen. Here, internal table tsFlight is declared within the select query using the keyword data and host variable @. It will create the internal table which will have all the fields selected from the table. The work area as well as the field symbol are declared within the read statement, which will have the structure of the internal table read. The same can be done in loops also. The variable is declared in between the source code as and when required like this. By doing all this, you save a lot of time and effort which you used to spend on the declarations. String expressions. You can now concatenate multiple strings and variables using ampersand operator and pipe symbol. Consider the source code given in the screen. Here, three strings are separated using pipe symbol and concatenated using ampersand operator. Two variables are also passed within the string in the similar fashion. Finally, the output string will look like this. The value 400 is passed from the system variable siMandate and the value AA is from the variable LVCARID. Constructor operators. These operators are used in constructor expressions to create a result that can be used at operand positions. The syntax of the same is given here, where operator is a constructor operator. Type is either the explicit name of a data type or the character hash. With the hash symbol, the data type can be derived from the operand position if the operand type is statically known. Inside the brackets, specific parameters can be given. The various constructor operators are given below. New, it is used to create data objects. Value, this is used to create values, especially in a structured type. Conv, this is to convert values. Cast, to perform up or down cast of references. Ref, to create data references. Exact, to perform lossless calculations or assignments. Cont or switch, to compute values conditionally. All these operators are elaborated in the further slides. Moving on to the constructor operators in detail, starting with the operator new. This operator creates an object for an anonymous data object or instance of a class. There are different variations for it. First one is new, data type and a value. This creates an anonymous data object of the data type given and passes a value to the created object. Observe the example given in the screen. Here, it is creating an anonymous data object of the type I with the value 1000. Another variation is for creating instance of a class. This creates an instance of the class and passes parameters to the instance constructor if any. For example, in this case, it is creating an instance of the class CLGUI where it is also passing the values to the constructor parameters. The third variation is creating with a hash symbol. This creates either an anonymous data object or an instance of a class, depends upon the operand type specified on the left. You may ask the question, how would the system know for which class or data type it has to create an object? Look at the example. When you compile this piece of code, yellow grid class reference is statically defined. When you use hash, compiler knows to which class it has to create an object. But you cannot write the same piece of code in this fashion. This doesn't work. In this case, compiler would not have any idea about for which class it has to create an object. Value operator. A constructor expression using a value operator constructs a value for the type specified. These have different variations. First one is value data type or with a hash symbol. It constructs an initial value for any data type. See the example here. Here, it creates an initial value and assigns it to the variable LV result. Second variation is to create a structure and assign values for each component. See the example. In this case, LW details 2 will have the same structure of LTY details with the initial values given between the braces. Third variation is for internal table. See the example here. Here it constructs an internal table. For each line, a value can be assigned. In this case, 2 lines are assigned to the table LT table. Conversion operator. A constructor expression with a conversion operator converts the argument given to the data type specified and creates an appropriate result. Consider the example. Here, two calculations are there and both produces different results. In first case, the calculation type is float and the result is converted to integer. In the second case, conversion operator converts each intermediate result to the calculation type I or integer. Hence, the results will be different for both the calculation. Cast operator. The casting operator cast is a constructor operator that executes an up or down cast for reference variables with the type specified in type. This is the syntax. In order to do downcast, earlier the operator question mark with an equal symbol is used. And in order to cast with this operator to a requested reference type, you needed helper variables. With the new statement, that is not required. You can use cast for an upcast. For example, with an inline declaration in order to construct a more general type. Here you can see a common example where a downcast is needed. Here, with the old approach, to use old operator, a helper variable is required. With the new approach, you can write a component selector directly behind the cast type. An example of upcast. The static type of the reference variable iref declared inline should be the interface, not the class. An example of using data objects with cast. For a constructor expression with cast, followed by the assignment operator is a left-hand side expression where you can assign values to it. Constructor operator reference. A constructor expression with a reference operator ref creates either a data reference variable that points to the argument or controls a table expression. Two variations are there. First one, if the data object is specified as an argument, the operator works like the statement getReference and creates a data reference variable as a result. Example, the iTab here is filled with value operator where the component dref is given a value using reference operator. Variation 2, if a table expression is specified as an argument, the operator ref controls the category of its result. Example, the result of the operator ref here is a data reference variable which references the fifth row of the internal table iTab. Exact operator. Exact is lossless operator that executes a lossless calculation. You might want to know what is lossless calculation. This kind of calculation actually introduced in release 7.02. A lossless calculation must not perform any rounding for a given value. If it does, an exception occurs. This is the syntax. Here, arith_exp is the arithmetic expression that is calculated lossless with calculation type DEC float 34 and the result is converted to the specified type. An example would be a best to understand. In this example, 7 by 2 has exact value 3.5. Hence, no exception is raised and we get the output. In other words, if we replace that to 7 by 3, whose result is not an exact value, and an exception is raised. Constructor operator condition. A statement with a condition will construct a result of the specified type that depends upon the logical expressions given. For example, earlier you used to write a conditions using if-else statement. The same condition you can replace it with now condition operator. Here that operator is used and inside the brace conditions are specified. Accordingly, the value will be passing to the variable vtime. Switch operator. This operator is much similar to the condition expression. There you have to use a logical expression, but here you have to use a constant value. For example, in this case, a constant value is compared with the system variable scilang. Accordingly, the result will be passing to the variable lvlang. Now we can learn about internal table operations changes. The major change is that you don't have to check the sizeof anymore. Instead, system only will raise an exception if the operation fails. Selecting an internal table or reading from internal table. Earlier, read statements are used to read from an internal table. Now that is replaced with a simple tab or internal table name and the braces. You can see the different variations here. Here you can see the comparison between old approach and the new approach. First statement, reading the internal table using an index and placing into a work area. The same statement is written in the new approach where the internal table with a brace, and within the brace the index is mentioned and the result is passed to the work area. The statement looks very simple here. Second statement, reading the internal table using the index as well as using a key. With the new approach, again the internal table with a brace. Within the brace, key as well as index is mentioned. The result is passed to the work area. Third statement, reading the internal table with a condition and moving into the work area. With the new approach, the internal table with the square braces, and within the braces, the condition is specified. The result is passed to the work area. Fourth statement, reading the internal table with a key as well as with the components and moving it to the work area. With the new approach, internal table is mentioned with the braces. Within the brace, key and the condition or the components are mentioned. So here what you have observed is the statement becomes very simple and more readable. For internal table, there are two new expressions or built-in functions introduced: line index and line exits. Line index. Here you can see the comparison between old approach and the new approach. Sometimes you may want to check the index value of the record read. So you write the code like shown in the old approach. Reading the internal table with the extension transporting no fields and then checking the site-abx value. Now with the new approach, you can write the same using the function line index. Within the braces, the internal table and the conditions can be specified. As a result, the variable on the left will have the index value. Another expression is line exits. If you want to check if a record exits in an internal table, you write the code like shown here. In the old approach, you are reading the internal table with the extension transporting no fields and then checking the size sub RC and taking it further. Now, with the new approach, you can simply mention the function line exits and within the brace, the internal table and with the conditions. Only if the record exits, the condition inside if will be true and then only it will go inside the if condition. By now, you have seen few of the new ABAP changes. Watch the part 2 of this video for knowing more. Also watch the demo videos to get more clear picture and complete the exercises to get hands-on experience on the same. All the best.